Let us consider energy. What is energy? The total work done. The total work done is called as energy. Since it is defined as total work done, energy and work both have same units, so its unit in SI system is joule. Work is a scalar, so total work is also a scalar, so energy is a scalar quantity. In nature, we have different types of energies: chemical energy, mechanical energy, electrical energy, nuclear energy, sound energy, magnetic energy, etc. We will find different types of energies. But now we are interested in mechanical energy. So what is this mechanical energy? It is the energy possessed by the body by virtue of its position or state or motion. This is called mechanical. Energy possessed by the body by virtue of its position, state or configuration or motion. The first part is defined as potential. So potential energy, simply PE. It is the energy possessed by the body by virtue of its state, position or configuration. State, position and configuration. Here we are interested the height or position. Imagine from the ground a body of mass m is lifted or taken to the height h. This is m mass lifted to the height h. What is the work done by the gravitational force in lifting? So W is taken as equal to mg is the force applied and h is the displacement. So this is called potential energy. Total work done is potential energy. When a body is lifted from the ground, due to the change in its position, the energy gained or associated with it is called potential energy, which is equal to mgh. Now if I consider the motion, this part of energy, mechanical energy, is called kinetic energy. So what is this kinetic energy? It is the energy possessed by the body by virtue of its motion. For a moving body, the associated energy is called kinetic energy. Imagine a body of mass m, originally at rest. Now by applying a force, it is displaced to certain distance and gains a velocity v. V is the velocity gained by the body. Now work is equal to force into displacement, F into S. So what is the work done on the body? Now here F is equal to ma. In this equation, A is v square minus u square by 2s. Since u0, it is v square by 2s. Substitute this value, then m into v square by 2s into s. If I cancel the term s and s, the remaining half m v square. This is what we call kinetic energy, because total work done is always equal to energy, and this energy is due to motion. It is called kinetic energy. So potential energy is mgh and kinetic energy is half mv square. Always the total energy sum of these two. This can also be written in other forms, because P momentum is nothing but mv. So here mv, if I multiply numerator and denominator with m, I'll get p square by 2m. Or this can also be taken as equal to half pv. So kinetic energy may be equal to p square by 2m or half pv or half mv square. The total mechanical energy of the body, total mechanical energy is always equal to potential plus kinetic. So total mechanical energy in anything is equal to potential and kinetic energy sum. Here we can define law of conservation of energy. What it suggests? According to this law of conservation of energy, energy can neither created nor destroyed. You can't create the energy, you can't destroy the energy, but it can be converted from one form to the other. Law of conservation of energy suggests energy can neither be created nor destroyed but only be converted from one form to the other. Any energy form can be converted from one form to the other. A chemical energy can be converted into electrical energy. Electric cell converts chemical energy into electrical energy. A heat energy may be converted into mechanical energy. Steam engine in heat energy is converted into mechanical energy. So always it is possible to convert energy from one form to the other. You cannot create or you cannot destroy. Here we are interested in mechanical energy. Only mechanical energy conversion. That means kinetic energy may be converted into potential energy or potential energy may be converted into kinetic energy. Let us consider a freely falling body. Imagine a body of mass m is dropped freely. So it is moving down, say from h height. At the highest point, total energy dropped. It is sum of potential and kinetic. So potential is mgh, kinetic is 0. So this is mgh. Let us say this is TE1. When the body reaches the ground, say it strikes the ground with a velocity v. If I call it as TE2, again PE plus KE. Here PE 0 because body is on the ground, h is 0 and it gains a velocity half mv square. So if you observe, as the body is moving down, this mgh slowly decreases and becomes 0, whereas this 0 kinetic energy slowly increases and becomes half mv square. So since total energy at every point is constant, TE1 is equal to TE2. This implies your mgh is equal to half mv square, or simply I can say loss in potential energy is always equal to gain in kinetic energy. In the case of freely falling body, the loss in PE is equal to gain in KE. Suppose if I take the reverse case, vertically projected body. Imagine a body is projected from the ground. So from the ground, let us say a body is projected upwards. It reaches to the maximum height where velocity becomes 0 and reaches a height h. At the starting point, total energy, same kinetic plus potential plus kinetic. If I imagine velocity is 0, velocity is v, kinetic is existing. As it rises the upward highest point, here the total energy so this is mgh plus 0. So if you observe, as the body is moving up, potential energy is increasing, kinetic is decreasing. So at any instant, loss in KE is equal to gain in PE. So this is the law of conservation of energy. As the body is moving up, it loses kinetic energy but at the same time gains potential energy. Here we can consider work energy theorem. What did this work energy theorem suggest? Work done by the applied force is always equal to change in its kinetic energy, half mv square minus half mu square. Work done by the applied force, F is applied. As a result, the velocity of the body changes from u to v. So I can say work done by the applied force is always equal to change in kinetic energy. This is called work energy theorem. Now, Einstein assumed that mass is also a form of energy. So because of this, he suggested that mass can be converted into energy and energy can be converted into mass, and proposed a relation, Einstein mass energy relation, E is equal to mc square. That means if I have a mass m with me, I can convert it into an energy equal to mc square. Or if you have energy E, then it can be converted into a mass equal to m. So this is mass energy equivalence. Now, other units for energy. Normally, we'll take electron volt. So what is this electron volt? Electron volt is the unit of energy. It is EV. It is the energy gained by an electron when passes through a potential difference of 1 volt. One electron when passes through 1 volt potential difference, energy gained is electron volt. We know that W is equal to VQ, potential difference multiplied by charge moved. So let us say 1 electron through 1 volt. So this is 1 EV. What is the absolute value? 1 volt. We know that the charge of the electron 1.6 into 10 to the power of minus 19. So this is 1.6 into 10 to the power of minus 19 joule. Therefore, 1 electron volt value is 1 EV is equal to 1.6 into 10 to the power of minus 19 joule. This is also used while calculating the energies. Similarly, another term is kilowatt hour. Kilowatt hour. It is kWh. What is the value of 1 kilowatt hour? Kilo is 10 power 3. Watt is joule per second. And hour is 3600 seconds. So if I cancel seconds, then it becomes 36 into 10 to the power of 5 joules. So the value of 1 kilowatt hour is always equal to 36 into 10 to the power of 5 joules of energy.